Mary, you got 2 wells? Oh my goodness.
All right. We're looking at,
Another wow, please.
we're looking up here. One thing. Page 780 thereabouts. Here we go, starting at number 4. Number 4A, they're asking whether it's arithmetic, geometric, both, or neither. If it's arithmetic, give me D, the common difference. If it's geometric, give me R, the common ratio. And if it's both, give me both. 4A, it's arithmetic, and D is equal to 7. 4B, everybody tuning in?
I'm listening.
I want to make sure everybody's tuning in on the answers so I don't have to repeat these needlessly. Number 4B, geometric. R equals 2. 4C, neither. 4D, arithmetic. D equals -2.
For A, it was D equals 7.
Correct. 4E, geometric. R equals 10.
Wait, what was that?
I haven't done that yet. 4F, neither. 4G is both. D is equal to 0, R is equal to 1. 4H, geometric, and R is equal to 3/2. Or you could do 1.5. Number 4I, arithmetic. D equals 7/2. You could also give me 3.5. 4J, neither. 4K, geometric. R equals -3. 4L, neither. 4M, geometric. R equals 1/2. 4N, arithmetic. D equals 1/6. And 4O, geometric. R equals 2/3. Any repeats on number 4? Yeah. K was geometric with R equals -3. Any other repeats? Yeah, Catherine.
What's N and L?
I'm sorry.
N
N and L.
O.
N and O, sorry. N is arithmetic. D equals 1/6. O is geometric. R equals 2/3. All right. H. It's geometric. R equals 1.5 or 3/2. Me. Okay. Any other repeats on number 4? All right, number 5. What number should replace the blank? 5A should be 22. 5B should be 324. 5C should be 17. 5D should be -23. 5E should be 6. 5F should be 125. 5G should be 6/5. 5H should be 5/4. 5I should be 0.025. 5J should be 1875, 1875. 5K should be radical 11. 5L should be -0.3. And it repeats on number 5. And number 6. A formula, they give you the formula, I give you the first 5 terms. They're as follows: 7, 9, 11, 13, 15. Yeah, 7, 9, 11, 13, 15. Part B, how are they found? Basically, what's the pattern? Add 2. And is, what type of sequence is it? Arithmetic. If you had to prove it, D is equal to 2. Let me grab my water. should, did I do number 7? Oops, sorry, number 7. Here are the numbers. 5 numbers are 10, 20, 40, 80, 160. Yeah. 6C was arithmetic. It repeats on 7A. 10, 20, 40, 80, 160. 7B, what's the pattern? Multiplying by 2. And what kind of sequence is it? Geometric. Number 8, what numbers should be replacing these if they're arithmetic? The numbers negative 30 and positive 90. Negative 30 and positive 90. If they're geometric, it should be 2 and 250. I can show you how to do those in a minute. In the second one, what are those 2 blanks in the middle? If they're arithmetic, it'll be 10 and 17. If they're geometric, it'll be 6 and 12. And it repeats up to number 8. Okay, number 9. Write a formula for the nth term. Oh my gracious.
Yeah, that's where I had a question mark problem.
I didn't know they were going to ask that. Sorry, my bad. I'm gonna hold off on that. Cause that was actually supposed to be notes today. This book is really fond of asking questions they haven't taught you how to do yet. Skip number 9. If that, I will not count that against you. So I'm gonna go around, and if you don't have number 9 done, don't worry about it. Number 10, that's sort of the same sort of thing we did before, so that one should be up and running. So number 10. Part A, geometric, R equals 3. 10B, arithmetic, D equals 9. C, neither. 10D, arithmetic, D equals negative 4. 10E, geometric, R equals 0.1, or 1 over 10 if you want. 10F, neither. 10G, arithmetic, D equals 2.5. H, geometric, R equals 1.5, or 3 over 2. 10I, both. D equals 0, R equals 1. 10J, yeah, go ahead.
Can you do H again? Sorry.
Yeah, it's geometric, and R equals 1.5, or 3 over 2, whichever one you like. Where was it? J? Okay. J was geometric, R equals negative 4. 10K is neither. 10L is neither. 10M is arithmetic, D equals 1 over 6. There's a trick to that one. 10N is geometric, R is equal to 1/2. And number 10O, it's geometric, R equals 3/4. And it repeats as number 10. Yeah. E, geometric, R equals 0.1. Jeff? F was it? Oh, M is in Mary? Yeah, it's arithmetic, D equals 1 over 6. Any others? Number 11, find the missing number. Number 11A, 112. 11B, 27. 11C, 25. 11D, 2. 11E is 14. 11F, 31. 11G, 1 over 4. 11H, 1 over 7. 11I, negative 512. 11J, radical 29. That's a trick to that one also. 11K is 0.042. 11L is 625. That should be it. Any repeats anywhere? Yeah.
What was, I?
11I is negative 512. Any others on the whole page? Okay, skip number 9 because I wasn't expecting them to do that. I apologize in the book for the app again. Any of the other questions? Open to. Yeah. What you got? Yeah.
Can we do
11 what? I'm sorry. 11J. Yeah. Grab that. Okay. 5 radical 26. 3 radical 3. 2 radical 7 and blank. There's not much of a visible pattern there. This is a whole number, this is a radical, this is a partial. You might say, well, okay, this went down by 1, this went up by 4, maybe, I don't know. There's a trick to it. Anybody tell me what radical is equal to 5? Radical 25. Does anybody see it yet? Go. Radical 27. Radical 28. Radical 29. That's how I got that. So you'd have to expand this out. This is really radical 9 times radical 3, which is radical 27. So you had to go back and unreduce it to see the pattern. They did that with some of the fractions too. Yeah. 11, I'm sorry, what? 11L? Yes. 625. 1640. 100. 250. Blank. So let's go from the beginning. Is it arithmetic? Are they adding a number over and over and over? Eric? No, because they have different amounts. Like this goes up by 60, this goes up by 150. Game over. It's not arithmetic. Arithmetic means you add the same number over and over and over. Like plus 10, plus 10, plus 10, plus 10. Are they multiplying the same number over and over and over? That's not as easy to see because it's not a whole number. Can you tell me what they're multiplying by to go from here to here? Anybody see it? You can do a decimal or a fraction, I don't care. Anybody see it? Go.
You multiply.
Correct. Now how do you find out what you multiply by? 2.5, how do you get that?
I just kind of guessed a little bit.
Yeah, multiplying by 100 means you move the decimal over.
Yeah, 250.
There's another way to do it. Anybody see it? If they're saying we multiplied, how do you go back and find what they used? Divide. Take 250 divided by 100, and you get 2.5. Which, by the way, if you tried this here, 100 divided by 40 is also 2.5. And 40 divided by 16 is eventually 2.5. So yeah, so you just got it. So R is equal to 2.5. So what you do is you multiply this by 2.5. So what is it? I don't know. 0, 5, carry the 2. Hold on a second. Yeah, I know. 10, 12, 50, and this is 500. So 6250, and steal back 1 decimal point, 625. Does that make sense? That was a tricky one. But if it doesn't look like they're adding, check and see if they're multiplying, even if it's a weird number. Take any numbers right next to each other and divide, and then see if that's the number you want. If they use the exact same number over and over and over again, you got a winner. Maria, question.
what one was that?
That was 11L, is the Lucy. Next. Yeah, Isabel.
Between 10 and
10m. Yeah, so I was expecting that one. 1/6, 1/3, 1/2. Oh, was it 1/2, 1/3? No, that's right. And then 2/3.
Love that one.
And they want to know, is it arithmetic or geometric, and then tell about it. There's nothing obvious. Like here, maybe a 6, subtract 3, subtract 1, and then add 1. This thing threw everything off. Here's the trick. It's a lot like that radical problem. Is there any other form you could write these in? There's 2 or 3 possible answers to that. What's one possible way you could rewrite those? Decimals, that's one way. I tried that, it didn't work very well. Common denominators. Like what? This, by the way, is a standard trick. If there's a bunch of fractions that seem to have nothing to do with each other, try a common denominator. I love doing that on tests, by the way. Look. So this is 6, 6, 6, 6. This one's the same. Yeah, I know. Can somebody do this one? Anybody? Trust. 2/6. What's this one? Maybe see the pattern now. 1/6, 2/6, 3/6, 4/6. Is that, first of all, is there a pattern going on here? Yeah. Isabel, does it look like they're adding or multiplying? Adding. What are they adding each time?
Well,
On top?
1/6.
1/6. Right. So this is arithmetic, because they're adding. And then D is 1/6. And that's it. Does that make sense? Yeah.
Why do you do 6 A, B,
6 ABC? Let me look. Yeah, 6A. T sub n, we're actually going to be covering this more today. The formula was easy enough to use, so I let the problem go. T sub n is equal to 5 plus 2n, where n is the counting number. Basically, here's what they're trying to do. I think they only needed 5. I'm just going to go to 7. Now, what does this mean? It means it's going to be T1, T2, T3, T4, and so on. These are the terms. In other words, n is just the number of terms. Right? It's the number of the term you're on.
Oh, kind of like
Like if n is 5, it's the 5th term. If n is 10, it's the 10th term.
kind of like the X thingamabob that you showed us however long ago. You did like X1 and X2.
Yes, exactly the same.
Oh.
Yeah, it's just keeping the different t's separate, because you only have one t in the alphabet and you can't use it twice. So this one, if I use a 1, so basically t1 is equal to 5 plus 2 times 1. Just calculate that. 5 plus 2, this would be 7. Okay. The second one is t2 is going to be 5 plus 2 times 2, which is 5 plus 4, which is 9. Make sense? And then this will eventually be 11, 13, 15, 17, 19, blah, 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 blah. And that's arithmetic. They're adding 2 each time. Okay, we wouldn't have known it's arithmetic without looking at the answers. So far. Next. Any other ones you want to dissect? Yeah. Say again, I'm sorry? 8A. Yes. So oh yeah, that's the tricky one. I'd like to do both of those, 8A and 8B. They gave you some mystery numbers and they say, what if it's arithmetic? It's blank, 10, 50, blank. Question. question. If it's arithmetic, what does that mean? Andy?
It means you're adding something to get, or, yep,
Right. Pretend this is arithmetic. What are they adding? 40. Do it again. 90. Go backward. Does that make sense? That's how you do number 8A. Now, pretend you have the exact same numbers, but it's geometric. Rosie, take this one. If it's geometric, what do you do over and over and over? Multiply. What must it be multiplying by? 5. This is adding 40. Do it again. Multiply by 5. 250. Go backward. 2. You divide by 5. Make sense? That's how they did that one. Did anybody want to see 8, C, and D? Those are a little more tricky than 8A and B.
Sure.
Okay. So it's having the inside ones missing is a little more of a trick. It's not too hard, but there is a trick to it. It's not as obvious. 3 blank blank 20. 3 blank blank 24. Let's assume this is arithmetic. You're adding in order to get something something then 24. Question. How many jumps? Done.
2, 3.
3. So we're going to add something, then something, then something, and then get 24. I have no idea what we just added. Does anybody remember the letter we used for adding repeatedly? That's for multiplying over and over.
D.
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 I'm going to call this plus D, plus D, plus D. Everybody look up here. This is the trick to find numbers that are missing in the middle. I don't know how much I added each time. I'm just calling it a variable. They call it D anyway.
Well, I do.
How many D's are there?
6. 3.
3. Would everybody agree that it's 3 plus 3D?
I do.
That's the key to the problem.
Yeah. What?
Equals 24. Now do it. Solve for me. Subtract 3. 3D equals what?
Yeah.
21. And then divide by 3. D equals
3.
7. Now do it. Add 7.
I
10.
knew it.
Add 7. Got it.
That I got.
Does that make sense? That's actually sort of a teaser into what we're going to be doing today. Let me try the D on that one. What if it's geometric? What if it's 3 blank blank 24 and we're multiplying?
I still don't.
Watch this. It's still 3 jumps, but we're not adding. If we're multiplying, what letter do you call it, Jack?
6.
I'm not letter and Jack.
Oh.
Other than that, that was great. What's that? R. So times R, times R, times R. Does that make sense?
Yeah.
If you're multiplying again and again and again, it's times something. I'm just calling it R because I don't know what it is. Can somebody give me the short version of R times R times R? Good. That's R cubed. This is 3 times R cubed equals 24. Let's try it.
I can do
Solve. Now the first step shouldn't be too bad.
it. Divide by 3.
Divide by 3. The second one you might have to guess and check.
You can use something.
Can you think of a number that's cubed that makes the number 8?
Yes.
Was it?
2.
2. You just
I
found what
used
you're
to.
multiplying by. Now do it. Multiply by 2. Don't work too hard. 6. Multiply by 2.
12.
Got it.
36.
Yeah.
Can we do
11 each. Yes. Now this one was not arithmetic and it's not geometric. They're not adding the same thing over and over, and they're not multiplying. They're just following a pattern. What do you expect the top number to be? 1 over 3, 1 over 4, 1 over 5, 1 over 6. 1. Guess what the bottom is?
Oh,
Yeah. So, by the way, that's not a bad instinct. If they're saying, if this is arithmetic, they'd be lying. There's no way you could add the same thing and get 1/3, 1/4, 1/5, 1/6 by adding the same thing over and over. Can you multiply and get 1/3, 1/4, 1/5? No. So it's neither. So in other words, you just wing it. It's kind of like the 1, 4, 9, 16, 25. You just follow your nose. Does that make sense so far? Any others you want to see? Present. 5 what? Ah. 5 F is in Franklin. Yeah, 1H2764. Look up here. And they wanted the next one after that. Is there any pattern on this at all? Apparently not. Is it arithmetic? Are they adding the same thing over and over? No, can't be. This would be adding 7 and this is adding 19 or something. Anyway, it's not the same. Multiplying, they would have to do times 8 times 8 times 8, and there's no way they're doing that.
So it's not 7. Wait, no.
It's neither, but that might still be a pattern. You see it? Close. It's not squared, but it's
Square root.
cubed.
Cubed. That's what I said. Wait, is it a 1 times 1?
And 5 cubed is 125.
Oh.
Does that make sense? That was sneaky. How do you find patterns that are not arithmetic or geometric? Best way is to memorize like 3 or 4 of them. They come up a lot. This is the one that books like a lot. Squareds and cubes, they like a lot. Expect those to show up. Questions so far? Any others? Now's a good time to ask. Going once, twice, thrice. All right, take out your notes, please. Today I want to talk about getting formulas.
I'm sorry.
I'm going to quote you. I think we can put that away. Yeah.
It's my notes.
Thank you. That was a maze. The other part is a maze. That's not, I don't think you could squeeze notes on that page if you liked it.
I think I could.
Here's a quote from my old high school math teacher. Formulas are powerful. If you can get a math formula, it eliminates about 90% of your need to memorize. We've been playing with patterns, and we've been kind of like feeling our way in the dark. You would say, okay, we're adding repeatedly, we're multiplying repeatedly, and then you just do it 20 times, which is okay. But I gave you a couple of problems the other day where I said, what if I want the 1,000th term? That gets really tedious. Question? Yeah, sure. If you can get a formula, you can get any term you want. If I say, give me the 10,000th term, you can get it right away if you have a formula. A formula is just something with variables in it. A formula is just anything with variables. Equations have formulas in them, inequalities have formulas in them. Formulas are anything with variables in them. Let me give an example. 7, 12, 17, 22, ...
That's not four, no.
What I would like to find is the 1,000th term. Doing this by hand is really, really tedious. Crystal, does anybody see the pattern?
Yeah.
Raise your hand.
Plus 5.
Tell me, go. Yeah. Adding 5. What kind, oh, see who remembers this. Is this a sequence? or a series?
Sequence.
Sequence, why?
I don't know.
All right, you're right. Why is it a sequence, Rosie?
Because you're doing the same thing as like, oh, a series is a list, and a sequence is something.
Other way around.
Oh my gosh, no.
Yeah, okay, go, Rob. You're on to something.
A sequence is like they're adding the same number that's
Other way around. Put your two answers together and it'd be perfect. Go.
A sequence is just a list.
Yes.
A series is when you add them.
Yeah, a sequence is you just comma, 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 list them. A series is when you add them. Series is plus, 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 plus. A sequence is just comma, 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 comma. Okay? So this is a sequence. Is it an arithmetic sequence, a geometric sequence, or neither? Eric?
Arithmetic.
Arithmetic. Why do you say it's arithmetic?
Because it's adding the same numbers.
Yeah. In this case, now if somebody says it's an arithmetic sequence and I say prove it, what I mean is give me the letter. Which letter do you want on this?
Is it D?
D. D equals what?
5.
5. That's the proof that it's arithmetic. If somebody says that's an arithmetic sequence, I said good, prove it. And say the proof is D equals 5. All right, I believe you. That I can test. Now, one way to get the 1000th term is just to do plus 5, plus 5, plus 5, plus 5, plus 5, until you get to the 1000th term. Do me a favor, write this above these terms. The book used a different, they used T1, T2, T3, which is okay. It's like term 1, term 2, term 3. I'd like to use A1, A2, A3, A4. T is fine. It's just it's older. It's most of the math books in the world use A. If you have a book that uses T, that's
So
fine.
it'd be A1000.
Yes. I'm looking for the term A1000. What is it? No clue. By the way, let's see who can do a little logic puzzle here. Can anybody tell me the one of two numbers it has to end in? Go. But Brennan.
Seven or two.
Go.
7 or 2.
It has to end in 7 or 2. There are no other choices. So could this be 500? Could this be 543?
No.
No, impossible.
It has to be 542.
The horse around this. Go.
I don't know why.
Okay. How to get the 1000th term without adding 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5 a huge number of times? I gave you a hint the other day. How many jumps are between the first term and the 1000th term? Go, Mary. Well, hold on. How many? You're on the right track. How many jumps between 999? To go from A1 to A1000, there are 999 jumps. Let me see why it's 999 and not 1000.
Yeah.
I feel like if you have 5 fingers, there are 4 spaces in between. Same thing. The number of spaces in between is always one less than the number of thingies you have. So if there are 1,000 thingies, there are 999 gaps. Every time you add 5, that's one of the jumps. How many jumps total? Trust. I mean, how many from here to here? It's staring at you. 999. How big is each jump, Maria? What are they adding each time in this problem? 5. They're going to add 5 how many times? 999 times. Is there a fast way to do that?
Yeah.
Go, Brent.
999 times 5.
Right. Here, now you have to start with the number you started with. 7 plus, it's going to be 5 times 999. Do that. By the way, I'll show you a shortcut on how to do that for a second, but go ahead and multiply that. Let me know what is this? Just ignore the 7 for a second. Go.
It is 5,000. without the 7.
Excuse me. Yeah, go.
Would be 5,000. No.
Without the 7.
Without the 7. It would be.
Which is 5 times 999?
4,090.
4,900 and
5.
missed a digit.
6.
Go.
95. Not 4,995.
Yeah, go ahead. 49.95. Correct. I'll show you a trick for that in a second. More listening, less talking. Catherine, take over. What's the final answer? Don't work too hard. 49.95 plus 7. Go ahead and do that. Add them up. It's 5 plus 7. Sorry? Well, let's do that from the end. What's 5 plus 7? 12. Clear the 1. Add. 9 plus 1 is 0. Barry. Just add. Gary. 5,002. That's the 1,000th term. Guaranteed. Does that make sense? Let me show you what I did. Here's the question. Can we find a formula for the nth term? Which basically means a sub n. Can we find a formula for that? The answer is maybe. Let's try it. 7, 12, 17, whoops. 17, 22, blah, blah, blah. And then I want to go to the nth term. Gentlemen, I would appreciate it. Focus on me, not on each other. Get in less trouble that way. Question. How many jumps? What was that?
N minus 1 times.
Why do you say n minus 1 and not n?
Because it's not the n, it's the amount of jumps in between.
Right. In between is always one less than how many things you have. If you have 1,000 things, like 1,000 terms, you're going to have one less than that jumps. How big is each jump on this thing? 5. How many jumps?
N minus 1.
N minus 1. Can somebody give me a formula for this? What number are you starting with, first of all? Go. Yeah. Like, what's the starting number? 7 plus, how much is each jump? Yeah, they're true. And then what's how big is each jump? What are they adding? 5 times n minus 1. There's your formula. A sub n is this thing.
Wait, where do you get the 5?
The 5 is what you were jumping by
Wait, so
in this particular problem, because you're adding 5 over and over. If they were adding 10, we'd put a 10 here. Yeah, question.
So basically, the first 2 digit things, the 7 and 5, they depend on what the problem is, right?
Right. This is going to be here, and this is going to be here. And I'll give you a more general one in a minute. But in this case, I want you to give me the 3,000th term. But I don't want you to do it by counting, and I don't want you to do it by even counting the jumps. I want you to use this formula. Do it. It works all the time. Once you do the hard work of putting the formula together, it will work for you. It will be your obedient servant. Rob, take over. Pretend that this is the 3,000th. 3,000th term. What is n equal to? Don't work too hard. 3,000. 3,000th term. Why can I not say that? The 3,000th term means that n is 3,000. Use it. And feel free to use calculator on this. 7 plus 5 times 3,000 minus 1. What do you get as final answer? 15,002? That's correct.
Oh, wait a second.
Any questions? Yeah, go.
Okay, sorry.
That was
So-
pretty much just 5 times 29.99.
So basically, you just you plug the 3,000 into the end.
Yeah, whatever term you want, plug it in this slot for n, and it will give you the answer.
Okay,
every
but it
single
also
time.
depends on the original thing.
Correct. Now I'm going to give you a more generic one. But I want to give you a quick mental math trick. I'll just squeeze it in over here. Does anybody know a quick way to do 5 times 1,000 minus 1? I don't know if you noticed, but 5 times 999 is kind of an annoying thing to do in your head. You're carrying blah, 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 blah. Yeah. Problem. Question? Answer? Distribute. Absolutely. This is an algebra problem. Distributing is perfectly legal. And look what happens. 5,000 minus 5, which is trivially easy. 49.95. If you have a really nice round number in front, that's actually how I did this in my head. This is 15,000 minus 5. And then plus 7 back. Make sense? Yeah.
Is it always gonna be something times n minus 1?
Yes. Because there's always n minus 1 spaces for n terms. Let me show you what I mean. If I just give you some generic formula, let me just use that formula one more time. 7, 12, 17, 22, blah, 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 blah. And this is a sub n. That's the generic. Again, this is a specific example. He's starting at 7. But watch up here. This is A1, A2, A3. We agreed that this formula was 7 plus 5 parentheses n minus 1. Question. Where did you get the 7 from? Jack. Where did we get the 7 from? I'm sorry? The beginning. In other words, A1. That's what it really is. The real formula is going to be here. A1 plus, where do we get the 5 from? John, where'd the 5 come from in this thing? Like, why do we say 5?
Well, you can subtract 12 and 7.
Yeah.
17, 12.
So you're finding out what you added. What letter is that? D or R? D. The 5 is D. You were looking at the absolute formula. This is the arithmetic. Nth term. This will work for any arithmetic sequence in the world. As long as you know it's arithmetic, this will work. D is the common difference. That's what you're adding by over and over and over. Let's try another one. Let's prove it to you.
Thank you. 50% common ratio.
Can somebody give me a formula for a sub n? You might be able to do it in your head. That's not sure that you do. Go. What comes first?
17.
17.
Plus 4 and minus 1.
Where do you get the 4 from?
The difference, common difference, and
4 parentheses n minus 1. You are done. That's how you get the formula for any term you want. Then, so what I'm probably going to do on the test is I will say, here's the sequence. I'll probably even say, here's an arithmetic sequence. Find D, and that's you have to do that anyway. And now find me the formula for a sub n, and then use it to find the 10,000th term, or something like that, or the 4,000th term. Does that make sense? That's what you can expect on the test. If you can do this formula, you got this formula. You've got arithmetic sequences nailed. This is the formula. Yeah, it's easiest if you memorize it, but if you know where it comes from, you should be able to put it back together if you forget
I have
it.
a question.
Real fast.
When are we gonna get those?
Is this on topic?
It's around now.
Let's wait on that. Questions before we go on? All right, I'm going to trade off two things.
Yes,
First,
sounds great.
have this memorized.
Okay.
I will eventually have formulas for geometric. So I want to make sure you don't get them confused.
I did it. It's
There's an nth term for arithmetic and an nth term for geometric. Shh, let's not discuss just yet while I'm talking. Everybody see where this came from?
Yeah.
So it's the first term plus, this is just how many jumps, and this is how big each jump is. You start at 7, and each jump is 5, and they're like, you know, if there are 1,000 terms, there are 999 jumps. So 5 times 99, 100 minus 1. This is where this thing comes from. So in general, it's the first term, start with that, plus the size of a jump. Let me just write this in. This is the first term. This is the size of one jump. And this is the number of jumps. You might want to scribble those in. It'll help you remember what the formula is. The formula does make sense. It can be a little hard to put together in the middle of a test, so I would encourage you to memorize it. But you can always reconstruct it if you get really desperate. Questions? Yeah, real fast.
It's class over.
Class is over in about 30 seconds.
What was the rest of the trade?
Wait, do we
What's
have
that?
more numbers?
So we had to memorize that.
Oh. If you that is actually your homework assignment for tonight. Memorize that.
Okay, let's go.
You do not have a book assignment for tonight. Don't get used to it. Homework 17B is going to be due. Wait, today's Wednesday.
Yeah.
I'm probably going to give you a bit of time to work in class tomorrow, and I would like the 17B done by the end of the hour, but I'll make sure I will actually whittle it down so it's shorter. How about that?
Sounds good.
All right, please stand before you put your stuff away. Oh, people in the back. Before you put your stuff away, let us pray. No riot. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Right? See y'all later. Yeah, please. That'd be lovely. Bye, everybody.